Hello, and welcome to the Grouping and Mapping course, Chapter 2, Lesson 4. In this video, we're going to create our Information Manager Irene's report. And in doing so, we're going to explore different options we have if we're having trouble finding the data within our model. This is Irene. Part of her job as the Information Manager is to track and mitigate the environmental impact of the project. In order to better facilitate this, we are going to create a report. This report will help give her an intuitive understanding of where in the model needs most of her attention. Her report will apply a heat map with a gradient across the model. This way, the cooler colors will let her know where in the model less of her attention is needed, and the hotter colors, red, will show her where more of her attention is needed. To create this report, we'll use the same three-step plan we've been using so far. We'll create our mapping, extract the data, and then present it. I will keep a visual of the step that we're on in the top right corner. The mapping we're going to create will be a simple one compared to Paul's. It'll be named Embodied Carbon with one single group, Aggregate, and its one property, Volume. This mapping is exporting the volume of aggregate material in the project. Aggregate material is better known by its derivations. Some of these are concrete and asphalt. This will be used as an estimation of the carbon footprint, or embodied carbon of the project. Although this may seem straightforward, as we're filling it out, we may find that it's otherwise. So let's jump into the application and begin. Let's jump straight into creating Irene's mapping. We'll create a new mapping. We'll name it Embodied Carbon. Next, we'll create the group. We'll name it Aggregate because it's going to group together the modeled aggregate in the project. Just like with Paul's groups, we will create our query using keywords. We'll use Aggregate again as our keyword and we'll hit apply, and nothing happened. Let's try a different word instead. Let's try concrete. And we'll hit apply, and we can see parts of the road become highlighted, but it's still spotty. When using this feature, we need to understand how different disciplines or teams use different terms. For example, Irene has been through this before with the different disciplines. She knows that the teams tend to use derivation of the materials as terms. For example, the team building the warehouses refers to as aggregate material as concrete and slab, but the team building the road refers to it as pavement and asphalt. When creating the groups by keyword, we have to use terms that we found in the design model. With all of our keywords together, we'll hit apply and we can see the full corridor is now highlighted. We'll save this. Just like when using this feature for Paul, the query that was created is simply looking for the keywords inside of user labels, class names, and the like. But with that done, let's start creating our properties. The property we need exported is volume. We'll use calculated property and we'll select volume. We'll name this calculated volume. We'll save, and we have finished our mapping. Let's move to the raw OData widget and extract that data. With the data extracted, we can see our calculated volume on the right side, and it's a little spotty. This could happen for a few different reasons. Whether it's because the element is actually two dimensions, or if it's because the element is not encapsulated. The volume may not be able to be calculated. There would be an alternative to finding this information, and that would be from the design application itself. Often, the volume will be associated as a property on the elements, and we can access that information. Looking back at our group, we'll add another property to it. We'll name this property volume. We'll quickly set the other details, and then we will select our properties. We will select ones related to the volume. Hit save, and now we'll refresh the raw OData table. And we can see that some of the elements that do not have a calculated property for volume now have a property of volume embedded in the model. But this introduces a new issue. Our environmental impact widget only accepts a single property to drive it. While we could update the widget in order to accept two properties, and then if one is undefined, we'll use the other one, we could take the same logic and apply it to a custom calculation. So we'll add a new custom calculation. We'll name this one just volume. And we'll add that logic using an if statement. If our volume property is 0, or if our property volume is null, then we'll use the calculated volume. Otherwise, we'll use the property volume. So now, let's double check this by using a raw OData widget one more time. And there it is. We can see that so long as our calculated or property volume is defined, our volume property is also defined. So, now that that's completed, let's present this data using the environmental impact widget. And here it is. It's now applied to heat map based on the volume property that we provided it. We can see the high end and the low bands. And with that information, we'll navigate around the model looking how the gradient is applied to each element. And we can see that there's lots of red around this tunnel. This makes sense because there's a lot of dirt that just needs to be moved in order to make way for this tunnel, as well as the materials going into it. Irene now has an idea where she should spend most of her attention early in the project in order to reduce the environmental impact. That completes this chapter. We've been learning the concepts behind the grouping and mapping APIs. We've gone over creating mappings and groups and their properties, and then how to specialize those groups for our specific use cases. But during this process, we've been using this application. In the next chapter, we'll learn more about this application, how it works, and the APIs that are powering it. I'll see you then.